Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews and on-site training. In this episode, I'm going to do a quick, I don't know how long, but a quick code review of the O3DE engine. Now, this is a game engine created by Amazon. This is the open sourcing of their previous engine called Lumberyard. All right, so this engine, the news, I believe, is fresh as of today, and you can find tons of articles about this, including VentureBeat, whatever. Like, everyone's talking about the fact that they have open sourced their game engine. I guess that was yesterday they did the open sourcing of it as the recording of this episode. So you can go to GitHub and you can access it. This is the O3DE project on GitHub. I've pulled it up here in CLion, which I always use CLion for doing my code reviews, so that shouldn't be terribly surprising to anyone. Now, I'm just starting in the CMake here, browsing around and trying to see what kind of navigation we can get and stuff. Now, one thing that I want to call attention to, first of all, is that this is in fact C++ 17. This commit here was made apparently just 4 months ago, but it is C++ 17. That's pretty interesting to see. Now, the other thing that I'd like to point out is that they are directly setting these variables set CMake Cxx Standard, and instead of using the more declarative style of saying this project requires C++ 17. And that is a setting that you would set using target compile features with a more modern CMake style. Now, this seems particularly interesting to me because I see that they require CMake version 3.2.0, which is just like crazy recent. I don't know why they would require such a new version of CMake but not be making use of the more modern CMake features. So we're just going to scroll around a little bit in the code here. And I have only spent just a few moments looking at this so far, so I'm not very familiar with it, and not even really sure where to look. Now, one thing that I will do when I'm not very sure where to look is to use this project called Lizard. And just run Lizard on here. And Lizard is a Python project that is going to do a cyclomatic code analysis of all of the files in here. And we're getting a list of all of the functions that are found, and then it's going to tell us like which ones have like weird complexity, very long line count, high number of parameters, that kind of thing. We'll let this run for a second. Wow, that took a long time to run, actually. I'm going to fast forward it for you all, but that was a pretty good amount of time. So we can actually see here a report of the most complicated files, and Lizard doesn't care what language something is in. So it has analyzed Python and Lua and C++. That's what I'm seeing at the moment. I also saw some JavaScript stuff scroll past. So we're just going to scroll up a little bit here. All right, so this is a report on things with a cyclomatic complexity. That's this CCN. I made this smaller so that we could actually look at it. Let's zoom in again. Complexity of greater than 15, a length of greater than 1,000. Most of this is like 281 lines. That's not so bad. Num lines of code of greater than a million, that would be really big, or a parameter count greater than 100. So we can see some of these things with a parameter count of like 11 and a cyclomatic complexity of 27. You know, that's not a trivial file. So let's go ahead and look at bitfiddling.h. Convert swizzle. All right, convert swizzle. We can see it takes, oh, wow, okay. That's interesting. We can see it's kind of confused our CLion a little bit here. it looks like. Or it's showing multiple implementations of this here. But it takes a uint8 pointer reference to the destination, uint8 pointer reference to the source. Okay, let's see how these things are being used. So this is a dereference of a particular memory address, ++ that's doing, oh my, that's doing C-style cast to a uint32. Okay, so that's almost certainly undefined behavior right there. It's just about guaranteed that that is undefined behavior. And I don't understand why it's casting it to a pointer, to a reference to a pointer, then dereferencing that and incrementing the underlying value, but not incrementing the reference itself. I don't think. I think it. Oh, here we go. Dest plus equals 4. Okay, so it is actually modifying the destination that was passed in. Let's see about source. Yeah, source doesn't seem to need to be a reference to a pointer. Okay, so that's interesting. And we can see that we get this kind of high cyclomatic complexity count because there's a fair number of like nested blocks and that kind of thing in here, but that's not that bad really. Not bad from what I've seen in my experience. Oh, here we go. Something with a cyclomatic complexity of 69, and that is in the I-indexed mesh, the mesh validate. Okay, so this is a pointer to a pointer. Whether that's better or worse than a reference to a pointer is, I think, up to your perspective here. We can see that CLion is indexing more and more of this. We're getting some sort of, yeah, if size of VTX IDX vertex index equals 2, condition is always false. Let's see what vertex index is. Okay, uncomment one of the following type deaths. All right, fine. So these are things that are compile time determined, and we're getting a warning that it's always going to be false, but that could be swapped out, I guess. So here's another C-style cast, and we see, again, high cyclomatic complexity because it's a relatively long function with lots of nested cases. And in fact, this is actually a relatively long function with lots of nested cases. So this is the kind of thing that stands out when you do like a search with Lizard. Now I'm going to keep going down this road because I find it kind of interesting. There's a cyclomatic complexity of 83. And there's ways to sort the output and all that kind of thing from Lizard. I'm not going to rerun it at the moment, though. Just kind of scroll this. Ooh, here we go. Cyclomatic complexity of 114 on NMR click. That's in the track code editor TrackView nodes. Oh, there's TrackView Node and TrackView Nodes. Okay, this is the on NMR click. Okay, so now we see that this is presumably using Qt for its UI here. That's not immediately clear. It's using things that look like Qt. But here's our on NMR click. Lots of pointery things. Again, I guess it's trying to figure out where you clicked and what kind of operation you want to perform. This is the kind of thing that could almost certainly be split up into Cell-Shape functions, and that would make it perhaps a little bit more readable, possibly. It's a lot of, well, something that looks like it really should be a switch statement. No, it keeps going. This is the same function still. So let's see, what do we learn? It appears that it's using Qt, but I don't really know because I didn't dig into that enough. Definitely see some complexity, see some weirdness with references to pointers. I'm not sure what to make of that. So let's go down into the Chord. Well, there's a lot here, so even knowing where to start. All right, here's some other mentions of Qt. Okay, it definitely is using Qt. Oh, so much C-style cast in here. Why are we doing all these C-style cast? Q color, because QColor must use double. I wonder if we can actually get there from here. No, that's just forward declared. Must use doubles, so it's trying to get everything down to floating point, okay. Except for when it is using doubles. So if red is less than or equal to 0.04045, then red is divided by 12.92. Else, take red plus 0.55, okay. All right, fine. Color gamma to linear. I don't know if these things should have comments or not. Maybe these hard-coded constants are completely obvious to someone who is an expert in color transformations between, I don't know, applying gamma and that kind of thing. But if you're not, then these numbers and the actual process happening here is a little confusing. Why are we doing double precision here? Why are we doing floating point precision here? I have no idea. Looks like it's using some old school cute style for each macros, or someone provided these for each macros instead of using C++11's ranged for. So I find that a little surprising. The project requires C++17, so that's something to be aware of. And again, I'm just looking at this from a C++ perspective, not from a game perspective or whatever. Yeah, I'm flipping around in here and I see this C auto log time. This should probably follow the rule of 0 or something like it, because if we've got manual destructor and lifetime management, then we probably need to delete the copy and move operations. Yeah, so this is a pretty classic example of an RAI kind of thing. In our constructor, we're getting what the current time is, and then in destructor just saying when how many seconds elapsed or whatever. Game clock ticks elapsed. Yeah, so a little bit of modernization there. Well, I just pick any random thing here, can't I? Yeah, a similar kind of thing, although this one's using virtual for its destructor, which probably is unnecessary because it is, let's see, oh, I can't find my C ref count base. That's interesting. It does, oh, this code might still be indexed, I'm not sure. But if the base class provided a virtual destructor, I don't need to provide a virtual destructor unless I'm doing something in it. Let's see if I'm doing something in it. I see, yeah, it is still indexing this. Yeah, I'm not doing anything in my destructor here, and I'm guessing that I've inherited a virtual destructor. Let's go try to track that down. Yeah, so that provides our virtual destructor for us, and then keeping in mind a C++ 11 mindset, and then we can just equals default this here, and then down in our gizmo, we don't need to provide this at all because we would have inherited it. And then in our header file, we can simplify this, and then we can consistently apply our rule of 5 or rule of 0 here. So I would suggest doing that for sure. This is, you know, a minor kind of cleanup kind of thing, but it's a good habit to be in because empty destructors are, well, they can really cause a lot of performance problems with modern compilers because it limits how the compiler can optimize your code. So I'm going to attempt to see if I can find any empty destructors. Okay, so that's destructors. Okay, there we go. And found hundreds of matches. Oh, interesting. Oh, very interesting. So we're seeing different coding standards throughout the code. Let's go ahead and just open this in the find window so we can click through it from time to time. Okay, more than 1,000 destructors declared. Okay, more than 2, 3, 4, 5, 6, 7. This is actually fascinating. I know this is a large code base, but 7,800 destructors declared is, well, it smells like something to me. It smells like code that probably just doesn't need to be there. Like, okay, here's an interesting one. We're explicitly defaulting the destructor inside the CVP file. Let's see if we can go back to its declaration here. Why did we do this? Why did we mention the destructor at all? It's possible that there is a reason, like maybe we need to put this inside of a unique pointer or something like that, and we need to tell the compiler that there will be a destructor coming up and it still needs to create it for us. But I don't think so. Most likely scenario is that this is just a performance hit for the fun of it, effectively. We've taken something that maybe could have been trivial and made it so that it's not. So I don't know, you know, I'm just guessing here. So this AZ module, I can't get to that yet. All right, let's look. Yeah, all of these virtual destructors here are unnecessary because they would have been inherited from their base class in Qt. So those are unnecessary. Similar issue. Okay, so I'm going to get out of code editor land. We can assume that the next probably 200 destructors in there are unnecessary. All right, so yeah, this stands out as interesting. And this is what I said when I noticed it, that this seems, we see different coding standards throughout here. This one is explicitly marked override. You're saying I am explicitly overriding the base class's destructor. But if the base class has a virtual destructor, we're going to inherit that virtualness for us, and equal defaulting this is completely meaningless. This code could just be deleted. Here's something that actually does do work in its destructor. Let's take a look at this. And I'm going to get hung up on this now at this point. Yeah, we don't see any of the other special member functions declared, did we? Where are we? So this class is defined in the CVP file. So this is obviously just a little local helper thing. Probably still a good idea to define the rest of the special member functions. Certainly am not going to complain if you are, you know, more careful than not when it comes to these things. We need better handling of our rule of 5 destructors, that kind of thing. It does appear that there's testing. That's always good. And it appears to be a fairly large set of tests. Oh, okay. This is interesting. It appears that they have their own implementation or wrapper of the standard library. Yes, in fact, it does seem that way. Wasn't expecting to find this. Class array. That looks like a pretty standard implementation of standard array, although it is all constexpr, which is actually very interesting because standard array fill could not be constexpr in C++17, which this says this requires, because standard fill, the algorithm, is not constexpr yet in C++17. So it's got an, that's fully constexpr, which I'm not going to complain about one tiny bit here. Yeah, okay, these things are constexpr. Definite props to that. I really didn't expect to see that in here. And then it looks like we've got fixed size implementations of list and vector and unordered map and unordered set. That's pretty cool, actually. Why we have our own unordered map, unordered set, and map. These things are all things that exist in the regular C++ standard library. So I don't, it's not immediately clear to me why you would just implement your own. It says ordered map container compliant with C++11's associated container, all keys are unique. It doesn't give me any comment here as to why we needed to implement our own. I would love to see a comment on that, but definite props for the ones that you did implement, getting them more constexpr than the standard library ones were. So it makes me wonder if these fixed things are. No, they're not. I see force in line. Yeah, that always raises an eyebrow for me. You got to have a reason as to why you forced in line. And the fixed vector is constexpr. All right. that seems like a great place to stop. So I'm a little sad that they felt the need to implement their own standard library that's compliant with the C++ standard library. I totally get the fixed vector, fixed list, those things, the fully constexpr array. I hope that they're actually able to take advantage of those constexpr things in other parts of the code. But that is just a little quick high-level browse through and minor code review of this code. Definitely needs to have like a consistency sweep done over it for things like how the rule of 5 is applied and destructors are applied and when and where constexpr exists when it can. Still really concerned about that reference to a pointer code. I mean, is anyone actually using that code right? I hope so, because, otherwise this game engine wouldn't work. But that's the kind of interface that's really, really easy to use wrong. So yeah, thanks for checking out this quick, although a little bit longer than I expected, code review of Amazon's recently open sourced game engine, and be sure to subscribe.